So now that we have this graph, what does this mean? What this means, there's many different things that you can derive from this graph, but you can see that your density, you can compare the densities of the different objects. You can say, well, gold is more dense than lead, and that's more dense than rubber, and rubber is more dense than foam. You can see that the objects that have greater densities sink, while the objects in water, while the objects with lower densities float on the water. Um, you can also mention that in order for us to really get a graph of density as a line graph, and we mentioned about getting lines in class, but when you think about it, the density line, the slope, because when we look at what density is, and I'm going to go ahead and open Word and do a little bit of um, a mathematical assessment here. When we think about what density is, we have slope-intercept form, y equals mx plus b. Density is like y. And then m, the slope, is grams per milliliter. So our slope really is density is equal to mass over volume. And of course, if something has no density, our y-intercept is just 0, which means that finally our formula is just slope-intercept form, mass over volume. But in order for us to get this formula, we would have to be looking at the density for a given object. So gold would have its own density line, lead would have its own density line, foam. So you would have to get different masses of gold, for example, maybe 4 different masses, and then you can make a graph of the mass per volume, but just for gold, or just for lead, or just for foam. So those are some of the things that you can take away. I'm just going to give you a few different takeaways that you could write down, the kind of scaffold for you. Um, maybe kind of give you some sentence, some openers. Okay. Um, my density graph shows that blank greatest density, blank second greatest, so on, right? You can kind of list the things that um, the objects that you analyzed and what their order is for density. My graph indicates that the following objects float: blank, blank, float, blank, sink in water. So that's another thing you could talk about. You can talk about, we use a bar graph to analyze density data, bar graph instead of a line graph. Analyze density data computer simulation because we would need um, mass, mass and volume data for a given um, type of object in order to use a line graph in which slope would be density object. And then you can describe that a little bit more. Now, what I don't want to see is that you copy this directly, identically to what I have here. You have to put in something in these blanks. Um, and of course, you don't have to put all of this, but you should put something here that you have gathered from your graph of the density of the objects that you analyzed from the computer simulation.